Yeah. Hello, everyone. Good evening, everyone. I'm P. Lakshmi from MEZIA College of Engineering, and today I will be presenting my internship project done at Amatex Information Technologies Private Limited. So, this is an core-based company which will be very helpful for EC students who are interested in core side, and basically, it will allows you to work with microcontrollers, and it will gives you lots of knowledge about the microcontrollers. And next, the title of this project is Washing Machine Simulation using picsimlab, and it is based on the PIC16 F8778 microcontroller. So this is a virtual washing machine which is the same as of a real time application. For example, the washing machine which we are using in our homes, it is also the same as the real thing. But here the only thing that is changed is here we are simulated this project in an virtual way using picsimlab. So it is an virtual project, and it is my internship project at Tech Information Technologies. So let us see the introduction of this project. So, coming to the introduction, this project simulates the behavior of a real-world washing machine using picsimlab and the PIC16F877A microcontroller, which means it is as similar to the real-time washing machine where we can see the functionalities like power-on sequence, washing program selection, water level configuration, and start-stop operation. Everything that the real washing machine done, it will be shown in a visual way in this project. And this is the introduction of this project. And this project we are using a microcontroller named PIC16F877A. So it replicates the key functionalities like power on sequence, program selection, water level settings, starts up control, door status detection, and the display of different washing phases. All these were implemented in embedded scene and simulated with virtual components like switches, buzzer, motor, and an LCD display. So this is the introduction of this project. Coming to the overview of this project, we can see that during this internship, my goal was to understand how embedded systems control real applications. And in this project, I have earned many things, and one of that is I got hands-on with embedded C, like how to see the codes embedded C. It is an programming language which is an extension to C language, and I have practiced that. So I got hands on with embedded C, practiced using pixim and designed a state machine based control logic. So the project taught me to simulate hardware components virtually. How the hardware components will be simulated virtually, as we know that we can use the hardware components in real time using like it's an hands on experience. But when how to simulate the hardware components in a virtual way, like a buzzer, switch, bulb. These are the hardware peripherals. So we can simulate these things in a virtual way using the software. And the project taught me to simulate hardware components virtually and improved my debugging and simulation skills with microcontrollers. Another thing that I have learned here is how to simulate and debug the codes, how to work with microcontrollers. As earlier I have said that this washing machine simulation is um, based on the microcontroller that we have using, and I have learned how to work with microcontrollers in this project. So it has strengthened my debugging and simulation skills with PIC16 F877A microcontrollers. And in the further you will know how it improved. And now the goals of this internship is I have learned embedded C programming. My specific internship goals included learning embedded C, understanding microcontroller based hardware simulations, and working with picsimlab, and how to apply real-time control logic. And finally, last but not least, developing a complete washing machine simulation interface. These are the things that I have learned, and these are the goals of my internship. And at last, I have learned all these things. And for these, Ametex helped me a lot. And next, coming to the embedded system. Till now, I have said embedded system. Washing machine is an embedded system. The refrigerator is an embedded system. Television is an embedded system. Smart LED is an embedded system. What is the embedded system? It is the combination of hardware and the software to perform some specific task. It is designed to perform some specific task. So this is called an embedded system. So another way we can also say that embedded system is a specialized computer system that that performs a dedicated function within a larger mechanical or electrical system. So it is embedded as a part of complete device that often includes hardware and mechanical parts. And I can also say that embedded systems are specialized computing systems that perform dedicated functions that combine both hardware and software and are used in appliances like washing machines, TVs, and even industrial robots. So they usually consist of microcontrollers, input-output devices, and logic programmed in languages like embedded C. So this is the overview of embedded systems. And next, coming to the key characteristics of embedded system, we can say that as I earlier mentioned, these are designed for a specific task. Everything that we are designing will be to use for a specific task. In the same way, embedded systems are designed to use for a specific task like washing machine control, etc. Usually, these are real-time systems with a strict timing constraints comprise both hardware and software. Together, hardware and software, then only it will be called as an embedded system. If one of the thing is not mentioned, like if there is no hardware, it is not called as an embedded system. If it's only consists of hardware and not software, it we cannot consider it as an embedded system. And mainly the things we are using in embedded systems are microcontrollers. These microcontrollers have limited resources like memory size, power. So the overall embedded system is often have limited resources. So those are memory, power, size, etc. And next, coming to the example devices of embedded systems are washing machines, microwaves, ovens, smart TVs. So as I mentioned, typical embedded system includes microcontroller or microprocessor, and it definitely there will be some input given to this. So the input device like sensor switches will be there in the embedded systems, and output devices and the software logic. The software logic means the logic for which see, now we are implementing a washing machine, means the washing machine should wash the clothes based upon the type of clothes. So the type of clothes is the logic. It should ask what type of clothes do you need, what type of clothes do you need to wash. So it should be asked in your real time washing machine in your homes. Definitely it will ask what type of clothes and how much time do you want and what is the water level. These will be also done in the virtual way also. So the software logic, how the washing machine is asking all those requirements of ours. So that is the software logic, and it will be written in the embedded C or assembly language. Next, this is the block diagram of embedded systems. It consists of a microcontroller. In this microcontroller, there will be a microprocessor, RAM, and ROM. RAM, it stores the code permanently. Uh, it stores temporarily, and ROM it stores the code permanently. And next, it consists of input ports, output ports, external circuits, and the physical devices. So this is the block diagram of embedded systems. Now, as we said that in this process we are also using microcontrollers, and we can also see that in the block diagram of embedded systems there will be a microcontroller. This is the main thing. This is the heart of the embedded system. Without the microcontroller, there will be nothing in this embedded system because it is the main hardware that we are using. So microcontroller, it is an integrated circuit, like it is an IC designed to govern a specific operation in an embedded system. It combines a processor, a memory, and input output peripherals all in a single chip. In other way, we can also say that a microcontroller is a small computer on a single chip that includes a processor, memory, and input output ports. So these are widely used in home appliances, automotive systems, and industrial machines. Uh, so this is the processing part. This is the processing part of the embedded systems. So this is about the microcontrollers, and it consists of the key components of microcontrollers are CPU, ROM. As we can, as I mentioned, ROM is a stores the program code permanently. See, if we are using in our mobile, let us assume that we are using a mobile, and whenever we are double tapping it, the screen should be on. Every time this should be done in the whole period of your mobile, it should be done in the same way. Means something the code inside running permanently. It's not the code running temporarily. The code is stored permanently so that whenever we are double tapping a mobile screen, the mobile screen will be on. This is the daily thing until or unless our mobile is switched off. Until then, it will be done. So there will be something running in the back end, right? So that is the code that is stored in permanently. Then this code will be stored permanently in the RAM or flash memory. ROM or flash memory. Sorry, it's not RAM, it's ROM. Now coming to the RAM, random access memory, it is the temporary memory used while running programs. Then next, input output ports, timers, counters, communication interface, and one of the best thing that is the microcontroller can be given is the ADC. It converts analog signals into the digital form. It uses switches, inputs as switches, but gives uh, something in the form of words or sentences on the display. Means the analog signal switch is converted into the digital form. And next, it can also provide communication interface facilities like UART, SPA, I2C, means which is used to talk to the other devices. This is the basic microcontroller. I mean, like it is about the microcontroller and the key components. And next, when it comes to the applications of microcontrollers, we can say that it is used in everywhere. Home appliances, automotive systems, consumer electronics, medical devices, communication systems, aerospace and defense, agriculture, etc. In everything, it is used in everything. Yeah, this is the block diagram of washing machine simulation system using microcontroller. This is our project's block diagram. See, whenever we are pressing on switch 5, the power will be on. Whenever we are using switch 4, the washing machine will be navigated to the other thing. Whenever we are using switch 1 as an input, the door status will be updated. Whenever we are using switch 6, the washing machine will be stopped or start. No, no, no. For start, we are using switch 5. So for stop, we are using switch 6. And the other things are to display the washing machine status, we are using LCD, and there will be a buzzer motor in our washing machine. So these are the things our washing machine will be controlled. The main thing is it will control, like it will contain a microcontroller within it. So this is the block diagram of washing machine simulation using microcontroller. And next, what is the microcontroller that we are using? As I said, the microcontroller, it is the main part in our project. And basically what type of microcontroller we are using means it is a PIC16F877A microcontroller. Why I have chosen PIC 16 FH778 means I choose PIC 16 FH778 because it has enough input output ports to connect all components like buttons, motors, and LCDs. So it supports timers, interrupts, and communication protocols, making it ideal for this type of simulation. So a microcontroller is a small computer on a single chip that includes processor, memory, and input output ports. So I am using this microcontroller. Next, and these are the key features of this PIC 16 F877A because yeah, you can see these. Yeah. Why I have used this microcontroller means it supports interrupts, timers for cycle timing and control. Mainly, it is easy to simulate using picsimlab with virtual peripherals. Here, this is the virtual washing machine, so all the peripherals that we are using will be virtual. And when we are using picsimlab, it is a software that supports simulation means this PIC 16 F877A will be supports easy to simulate using picsimlab with virtual peripherals, and it is also supported by MPLab and X8 compiler for simplifying development. And there these are the some features of PIC 16 F877A as you can go through it. Next, this is the architecture of PIC 16 F877A. Now, let us come to our project finally. So, our project design. The washing machine was designed using a state machine model. So, the user inputs are taken via switches. The system shows statuses on an LCD, and controllers like motor and buzzer are simulated in picsimlab. Okay, I will explain about this project design. Simply, see, our project is designed using the microcontrollers, and how the project will be working means whenever we press a switch 1 to switch 6 there will be some operations done in our washing machine, and I will show how it will be. And next we are using some virtual peripherals like CLCD like screen, motor, buzzer, and these are the things. And next, in our project, there will be some state transitions from powering on to the program completion, function execution and completion. And this project design, I will be explaining in the project demo along with the project demo. Coming to the embedded C. What is embedded C? It is this extension of the C programming language and used to develop firmware for embedded systems like microcontrollers. As I said, in the microcontrollers, we will design the embedded systems. Sorry. As I said, in the embedded systems, we will use the we will design the embedded system for a specific task. Specific task means there will be definitely will be some logic within it, and this logic will be stored permanently and it should be done run every time. So for this logic we will be using some assembly language, and that is nothing but embedded C. That I have here I have used embedded C. So this is embedded C is an also kind of C programming language, but it is an extension of C programming language. It will be same as of C programming language. And these applications of embedded C is home automation, automotive, medical devices, and consumer electronics. So embedded C was used to write the control logic. Unlike standard C, embedded C allows direct interaction with the hardware registers, and it is optimized for devices with limited resources like microcontrollers. And the other project requirements I have used is MPLab and picsimlab and MPLab XC compiler. Let us see what is MPLab. MPLab is a software which is an integrated development environment for programming and debugging microchip, microcontrollers, and digital signal controllers. Here washing machine is an embedded system and it is developed using a microcontroller. Then how we are implementing our code for this PIC 16 F877A means using the MPLab. Here the programs will be written. It is used for writing, compiling and simulating code for PIC microcontrollers. So MPLab, it is an integrated development environment that is used to converting the embedded C code into mission readable format for PIC microcontrollers. Again I will repeat, MPLab was used for writing and compiling the code, while picsimlab, let us see about picsimlab. So this is the picsimlab. Picsimlab allowed me to simulate the complete system without any physical hardware. So picsimlab is a powerful simulator which is used to simulate the microchips PIC microcontrollers. So what are the features that it is containing means simulation of PIC devices means microcontrollers like PIC microcontrollers. Here this picsimlab allows you to test and debug code without physical hardware. Without using any physical hardware, the code will be simulated, and the peripherals like timers, UARTs, GPIOs, other peripherals will be also be simulates. Next, in this picsimlab, debugging and testing will be very easy. And as we know that it supports code development and testing, enabling you to write, compile, and simulate code. Where this is the features of picsimlab, and that is why I have used picsimlab. Next, coming to the MPLab XC8 compiler, it is an XC8, the XC8 compiler is used for converting embedded C code into machine readable format for PIC microcontrollers. The code we are writing in the MPLab will support writing the code, and this code will be simulated in the picsimlab, and in the middle of the process, the program will be convert should be converted into the machine readable language. So it will be done by this MPLab XC compiler. So XC compiler will be converting the code into machine readable language. So it not only supports 8-bit, but it also supports a 16 and 32-bit devices also. And it integrates with the MPLab X IDE, providing a streamlined development experience. This is the logo of MPLab, and this is picsimlab, and this is MPLab XC compiler. Now coming to the components map, this components map will be also be proved in the program demo project demo. So components mapped is switch 1 is given as door status, switch 4 is given as to the navigation and selection in menus, and switch 5 is given with the function power on or start, switch 6 is given to the function stop and go back, LCD means which is used to display, buzzer. Buzzer means buzzer. It alerts when the door is open. So motor, it is a virtual motor which simulates wash, rinse, spin operations. I will show these three operations and how the switch 4 is navigating and selection in menus. So development process, these are the four required things. First we have to analyze what are the requirements that is that for and like first we have to analyze what are the requirements for our projects. Like the requirements of these projects are MPLab, picsimlab, and XC compiler. So first we have to know how to use these three, and next design and prototyping. What is our requirement, what we are preparing to design, first we have to know this. And next, to design this and what we require, after the requirement analysis we have to know code implementation, how to implement our code using picsimlab, MPLab, and XC compiler. And next, after implementing, after completion of project, we must check how the program will be running, how our project is going on. We have to test with different things in different ways so that the project will be in a good condition. So this is the fourth one is testing in picsimlab. Next, coming to our project, all these I will be showing in the project demo. Don't worry. But at present, I I will explain. So whenever we press on the switch file, we will get before pressing on the switch file, we will get this. So press key 5 to power on washing machine. To power on the washing machine, to start the washing machine, we have to press the switch file. After the switch 5 is pressed, it will be showing powering on the washing machine. See, I will see it. Yeah. This is thing. After the switch 5 is pressed, it will show this thing on the screen powering on the washing machine. After powering on, it will be shown some washing programs. It will navigate us to the washing programs. Means when the switch 5 is pressed, after the powering on, it will gives program washing machine program selection and navigation. Means what type of clothes we are using, heavy, dedicates, whites, bed sheets, and what type we want, rinse, press, dry only, wash only, aqua store, what are the things that we wanted. So next, after the switch 5 is pressed, it will takes us to the these things. Next, if we want to go to the next option like daily to heavy, we have to press switch 4. See, using the keypad switch 4, we can scroll between the options available. But if we want to select the one thing option highlighted with a asterisk, then we have to long press the switch 4. Long press the switch 4. Next, after we are selecting some level, after selecting the um, after selecting this washing programs, now we have to select water level screen. Means example, see, let us take an example. Let us take an example. Say if you are having only one pair of clothes and you have used it only for 1 hour, so you will be using only small quantity of water. But if we don't have an facility to select the water level that we wanted, there will be a wastage of so much of water. So for one pair of clothes, you need only some water, and that some water you can select in this water level. So whenever we press after the completion selection of washing program, now it will be navigate us through this thing. The screen will be presenting this thing, and in this, if we want to scroll down again, same we are using switch 4, and if we want to select, then we have to long press the switch 4 and it will navigate us through this thing. If we want to start the washing machine, we have to select switch 5, and if we want to stop the washing machine, we have to select switch 6. So after this, the screen will be appearing with like this thing. Like what are we doing? Washing, drying, spinning, what we are doing and what time we should wait. And if we want to stop the washing in the middle, we have to press switch 6. And switch 1 is for door, switch 5 is for start, and switch 6 is for exit. And next last, completion status screen description means after completing the washing, it will shows this thing, completed remove cloths. Let us see our project demo going through MP Lab. Now these are the programs I have written. Go to the main 1.c and start build. Once the build was success, go to picsimlab. Picsimlab. And next you have to load the project. Go to file and load hex. Already I have this, so I am opening this, and now my project was load in this. Now see, present press key 5 to power on washing machine. In this washing machine, I have given as RB4 as a switch 5, RB3 as switch 4, RB5 as switch 6, and this RB0 is the switch 1. Here we can see a buzzer. This is the PIC16 F7 F877A microcontroller. Next is switch 5. Yeah, I have on the switch 5, so it's showing powering on washing machine. RB4 is equals to switch 5, RB3 is equals to switch 4. Now, if I want to scroll down next, so simply use RB4, RB3. RB4 means switch 4. Now it heavy, dedicates, whites, stains, eco cottons. Now I am using eco cottons to select this long press eco cotton. Yeah. Now coming to the water level, if you want to scroll again, use switch 4, low, medium, max, high, auto, low. I am using low. So long press this or switch 4. Now to start, I have to select switch 5. Switch 5 is nothing but RB4. So my project is going on, the washing machine is rolling, and if my door is open, as you can hear, the washing machine is stopped and it will be indicating using a buzzer sound. The door is open, and if we want to stop, we can use the switch 6. Switch 6 is nothing but RB5, and I don't want to stop right now. So after completing, it will be indicated using buzzer sound, and again it going through this. So after completion, you have to reset it, and again you can start your project. And without resetting, don't close your project because it's not good. So this is my project. Coming to the conclusion. So I have learned embedded systems implementation simulated. We have simulated a real world appliance like washing machine. So it improved project planning and teamwork. There are many benefits from this project where I can simply say in 4 lines. So, to conclude this, internship gave me real insight into embedded systems development, and it helped me combine theory with practical implementation. This project forms a great foundation for future work in embedded automation and smart appliance development. So, I encourage everyone to do these kind of projects so that you can fill into your resume. Okay, this is my project. Thank you for your attention. I would be happy to answer your questions. Thank you.